Thanks a lot. Everybody can still hear me. I won't touch any other muting buttons. Yeah, it's really exciting. I'm working with a web team now, and they're using Cypress, which is a way of doing UI testing on web, and they're starting to use robot pattern as well. So it's a very high level and can be used anywhere. Thanks for the awesome intro. Yeah, I work at Capital One too on the identity team in the US. Done Android now for too many years, like 8 or 9 years. And this is actually a presentation that I originally did like 3 years ago. I updated a little bit of content, but a lot of it still remains the same because of like kind of the state of where Android is and where Espresso testing is. There's a lot of really cool stuff coming down the pipe for Android with Jetpack and Pose. I looked that up last night and have a little bit of insight into the way they're going to perform UI testing there. And it's something we should definitely talk about in this, not in anything you're doing today, but in the fact that, in about a year, Jetpack and Pose will be stable. So we're going to be starting to write Android apps and that. We need to be able to understand how we can test that. Yeah, you can follow me online as Handstand Sam. I also blog at handstandsam.com, so feel free to check that out. So your dream espresso test suite, let me move this out of the way, is going to be one where you have, it's easy to write, it's very low maintenance. UI tests are added during the development cycle. Every single time I have a new feature, I add a new UI test for it. It's hermetic, deterministic, and targeted. That means like there's no outside factors. It's always going to operate exactly the same way, and it's going to test this exact feature. It's going to run on every PR, so we always know it's going to pass even that very first commit. And we want it to have a reliable test execution environment. So when I do put in these new tests, they're going to run every time. So automated screenshots too are really helpful too, and we'll talk about why screenshots. I'm a huge fan of them in UI tests. So have you seen The Wizard of Oz? The old film. This is Dorothy clicking her heels together, trying to magically go home. So this is why it's special. So the question is why espresso? I actually ended up clicking on a random Twitter link the other day. Valera, I forget his last name. He works at Slack now, but used to work at Google. He actually created Espresso back at Google in 2014 or something like that. But Espresso is really cool. It basically leverages all the ham crest matchers. If you've used those before, it's a Java library that lets you match things. And so Espresso is created by Google. It has access to app internals, which is really cool. Some of the UI testing frameworks I've seen in the past have been using Ruby and Cucumber and some, I even forget the name of the framework we used originally, but it's things that kind of look from the outside looking into an application. What's nice about Espresso is you can get that kind of interaction, but you can also look at everything underneath the hood. You can look at what your data models look like, what your databases look like, what literally anything is going on inside your application, and that is a huge benefit of writing an Espresso test. They're super easy to write. We'll walk through some of the syntax. They're blazing fast because of things like idling resources, which only wait until your app has done anything that you need it to do, and we'll move on. So if you're using Espresso, there's this really cool table they put together. I kind of clipped it out so that we could look at it really quickly. But cool keynote animations. If you look on the right side, there's basically on view, perform, check. So these are the three things we want to do. On view, you'd use one of these ham crest matchers on the left. So with the ID of whatever it is, with the text of this, with the hint of this, whatever these are, you're basically you're getting the view that you want to do your assertion on. The next thing is you want to potentially perform an action on that. So you can click, double click, scroll, whatever else you want onto it, clear text, inner text, or you can check something, an assertion. So you don't have to perform all three of these, but you need to find your view, and then you can do a check or perform something or both. And this check could be does it exist? Is it visible? Is it above this? Is it whatever else? So when you talk about a UI test, being able to find the views on the screen and interact with them and assert things is what you need. So Espresso provides that in a really nice, readable syntax. The example here is this app on the right. It's got the little username, password, login. And so on the left, we have some yellow code showing that on the view with the text shopping app, make sure it's displayed. So it's making sure that this red box on the right is actually getting displayed. Great. Next thing, it's going to go down and do an assertion for the username field. So it's going to say on the view that has the ID username, which we've set in the program, go ahead and perform typing of text Sam. So it'll actually do that at the end. And finally, on the view with the text titled login, go ahead and perform a click action. I think there's a little video on that, but maybe there's not. Anyway, it would just do as you'd expect. I was talking to Rob a little bit earlier today, and there's a lot of content in here. It could probably last an hour long. I've got everybody on video, so feel free to ask questions at any time. See a lot of familiar faces, new faces, but just feel free to chime in. Espresso Test Recorder's there. If you've never written an Espresso test in your life, I highly recommend it. I actually have a course I did about it on caster.io, and it's like an eight-part course. It's not super complex, but basically you can go in and record an Espresso test. It's awesome for beginners. Basically, if you don't have any tests at all, it even sets up the testing structure, all the source packages where they need to go. But the problem is it only really works on simple tests. When you get into anything complex, anything reusable, it's not really going to do a great job. Also, it's pretty slow. And the generated code kind of sucks. So you basically just go in, you say record an Espresso test. It waits for the debugger because it's actually going to have to intercept all the click events and understand where all the views are to actually record this test. Then we're going to go in and basically as you go along, it'll record your actions. On the left, I typed into the username field Sam. I typed in the password field password, and I do these things. And then you can add assertions in. So it's there. It's kind of helpful. I double-checked last night in Android Studio 4.1. It's still there. Looks like it's going strong. So a thing, when you're in an Espresso test, when you use those ham-crest matchers to find a view, it's important to figure out what the view IDs are and what the view hierarchy is and what the text is inside of there. And sometimes, especially when you maybe didn't write this feature in the first place, or even if you did, you don't understand how it all pieces together, you can use this thing called Layout Inspector. And what it does is you kind of select the process you care about. In this case, I have a sample project called Shopping App. You would open it up, and it looks slightly different now, but the concept is the same, where you have a screenshot on the right, and there's little draw boxes drawn around everything. And that's basically saying this is where the view boundaries are. Maybe I have padding, maybe I have margins, and things like that. And on the left side, it is your hierarchy view of all of your view elements. This is a DOM structure, would be an HTML or anything, but basically it's box in a box in a box in a box, like any sort of view system that we have. This is a big call out here. I've seen it in a lot of scenarios, but who should write Espresso tests? And without even reading it, or I guess we'll read the underlined things. Espresso is targeted to developers, and its full power is unlocked by those who are familiar with the code base under test. So the big thing is it could be used from an outside perspective, like black box testing, but we don't want to be on the outside looking in. We want to be inside the app testing everything. And still acting as if we're from the outside, right? So we're still going through those flows, but being able to control everything. So the reason why this is in Google's documentation, it says it's for developers because the best tests can be written by developers. Obviously, a lot of other people can have good ideas for what tests are, but you're most empowered doing it as a developer. So I encourage you as developers, it's not your testing team's thing, it's everybody's thing to write great tests. When should you write UI tests? We're talking about UI tests now, and I've said that Espresso is blazing fast, but that's compared to somebody interacting with the screen itself, or some of the other testing frameworks that are out there. UI tests are still slow when you compare it to a unit test, which is just running a line of code. So avoid avoid UI tests unless necessary. Make sure you're only testing the UI. If you're testing things that don't include UI, like if you're testing your networking layer, you're testing your business logic, things like that, use something below the hood. Use a unit test, or use a test that just uses those components, because it is possible to write an Android test that runs on an Android device that does not actually display a UI. So you could go in, make a networking call, write something to a shared preference or something like that, and that's still a valid test. It doesn't have to actually show anything on the UI. The main thing with Espresso tests is make sure it's small and targeted. Espresso test really shouldn't, there might be one smoke test you have that goes from the very first page of your app, the first time you log in, and then you go do a bunch of stuff, and you log out, you log back in, you do all these things. But the longer your test is, the more likely it is to be fragile and break for some reason, right? It's not because the test is wrong, but there's just a lot of things happening on the system that might cause it to go wrong. So we talked about Espresso's fast. It's faster than other frameworks. Why is it fast? The reason why is because it's aware of the Android's main thread. I believe iOS has the same concept, but basically there's a UI rendering thread that is used to put content on the UI. Android's main thread represents that, and if you do too much work on the UI, there's a thing called screen jank, where if you have an animation coming in, but you're really processing stuff in the main UI, you'll see skipping of frames. So the idea is you want to put everything you can off the main thread, but the main thread is the render loop that happens on Android. So Espresso can monitor that and basically determine when that goes idle, when nothing's getting drawn to the screen or when nobody's using it, I can go ahead and do my assertions. It's also aware of the async task thread pool. So this is a thread pool that you can use to override any of your coroutines, or that you can add into any sort of like async kind of operation. But you can also write your own idling resources. And an idling resource is your custom code that says, Espresso, you will wait for this thing to be done, and then you can continue on. There's a thing called a counting idling resource. I don't think it wasn't shown on there, but basically you can say, there's 3 of these things happening. No, there's only 2. Now there's only 1. Now none are happening. Go forward. So it gives you this ability to just count up and down. So if you have network calls happening, or if you have some operations happening you want to wait for, that's your way of tracking those. The big call out is never have thread.sleep. If you've written UI tests, you've probably done this. I've done it 1,000 times. But what it's saying is, hey, just wait 5 seconds, right? That's what it's. It's a time, like something. The screen's going to render. Everything's going to be perfect in 5 seconds. I promise. And so in doing this, usually it'll pass the test and it'll be fine. But realistically, if the screen's trying to load, it might actually load in 1 second. So why do you want to wait those extra 4 seconds? Or sometimes maybe it'll go load in 10 seconds because something weird is happening, and so it'll actually fail at that point in time. So if you use Espresso's like built-in tools here, idling resources and leveraging their monitoring of async tasks and main thread, then you don't have to do sleep because Espresso is actually waiting for you to do the next assertion. So you don't have to like tell it a certain time. This gets a little down in the weeds, but this is good stuff. So we already talked about the way you find a view. So on view matcher, I grabbed a view from the UI. So one of those boxes out there, maybe it's a button, maybe it's a container, edit text, whatever. I basically grab that, and now I have my interaction. Once it's synchronized, meaning that like the whole Android system, all the idling resources, async tasks, everything else have like stabilized. Now we can actually go ahead and find the view, search the hierarchy, and execute the interaction, the perform click or the check it exists, and so forth. So the interaction itself is just that hand press matcher. We're going to wait, we're going to do our action, and be done. That just kind of gives you some insight into like what's happening behind the scenes in Espresso Test. You definitely want to disable animations for Espresso testing. Animations are beautiful, but system animations do cause timing issues, right? So if I've got this cool fade up or fade out, if I'm looking for an element on the screen, it may not be there completely because it's fading in or fading out. So if you turn those animations off, you're going to have better success rate. So there's some new flags that you can put in your Android block of your Gradle files that actually do disable animations. It's part of the test orchestrator. I don't think I call it out here, but it is in the documentation, the Android documentation. So yeah, definitely use idling resources like we called out. Utilize the async fast thread pool. And now comes my greatest moment of Keynote in all of my life. So people talk about magic move. This is my best use of it ever. Here we go. Ready? So you have 5 tests in Android. They're all doing awesome stuff. Thank you for writing tests. Everybody's super happy about it. Now, all those tests are testing the device, obviously. But something changed. And now all those tests are broken. So let's just say that your button, their login button, the ID changed from sign in to login or something like that. Now all of these tests are broken. So that sucks. But what if we had a robot interact with it, and that robot had one way of interacting with to perform an action called login. And that could either use the ID, login, or sign in, or whatever it ended up being. The test itself would talk to this robot, which the idea behind it, Jake Wharton, I piggybacked on his talk. He's the one that gave me this inspiration for this whole thing I did, and then I added all the screenshots to it. But if you go ahead and if your test is like the instructions you're giving to a robot, so pretend a robot's sitting there at your computer, right? And you're like, log in, and then you're like, make sure this exists. Like those are the sort of things a robot should be aware of. These high level what you should be testing, but the how it's actually doing testing is within the robot, and that way you're not coupled. That when that ID changed, it's how you're testing it, not what you're testing. So if it does fail, the robot is the only place it's broken. So you go ahead and fix that. now you have 5 happy paths. So it's that separation of what I'm testing and how it's actually implemented, the IDs, the text, and so forth. And by doing that, you've just like any good architectural framework, you've separated to have layers of separation. What I'm testing, how I'm testing it. Same way you use like interfaces and things like that. Like the underlying implementation doesn't matter. I just want to use this interface to do something. Or what do you guys call it in iOS? It's not an interface, but it's something like that. It's protocol or start. So here's an example of using a robot in Espresso. So you'd have, in this case, a login robot. Typically, a screen robot would be a robot per screen because each one is going to contextually have different things, each screen. So in this case, on the right, it's got a little awesome animated GIF. It's typing in Sam, password, remember me, login. So that's what this robot's going to do because it's going to type username Sam, password, toggle the remember me button, and log in. So when you look at this is what you want to do. How it's actually being done, you don't know what ID you're selecting and things like that, but it doesn't really matter to you from the outside. This is like going into what that login robot could be implemented as underneath the hood. One thing that I've done here is use the builder pattern. So if you've done that, it's basically the ability to do continuations or chainables. So when you look at the syntax in the very top line, login robot dot username dot password dot, it's allowing you to keep saying like dot this, dot that. And you can do that by returning the original object. So in this login username function that's highlighted, the big section, we pass in a username. Underneath the hood, it's going to find the ID of the object username, make sure it's displayed, and then perform a replace text inside of there and close the keyboard. Everybody loves the Android keyboard. So anyway, it'll do all that for you, but at the end of the day, what you wanted to do is just enter a username. The same thing for password. Same thing for remember me. It's going to scroll to it. It's going to click on it. And finally, your login is just going to perform a click for you. That very first line up here is that what we just walked through that scenario. But if you're going to have a more complicated test that goes through multiple screens, it is recommended that you write a robot per screen. So the home robot here would know how to pick a category from a recycler view or a list view or whatever that might be. It's going to click on the item that says fruits. The category Apple is able to look at this sort of recycler view and scroll to the right portion that says pineapple, and the item robot has the ability to add the cart. And so the good news is about writing this like per screen is it gives us nice contextual methods to it, right? You're saying what I want to test on this screen, and it just provides a lot of flexibility. So I did a talk at DroidCon New York City in 2016. This is dating me, isn't it? But it was about, it was called Espresso, a screenshot is worth 1,000 words. It's that whole thing that like visualizing something is so important. And screenshots, like we did make a library, a Capital One here called Easy Screenshots, which is a wrapper around some other libraries, and we'll touch on that in a minute. But taking a screenshot when you're doing an action inside of a robot is so helpful because every action a robot is doing, you're able to say, oh, this is a step that I'm doing, right? It's what I'm testing. I'm going to enter this value. I'm going to click on this button. And so inside of this robot where I typed in username, at the very end, I have take screenshot, enter username. And so now it'll take a screenshot of the username already being entered. Next thing here is you have an action occurring. So when you have an action, it's important to assert that it's there, say it in a future tense. I'm going to be logging in, take a screenshot, and then click. We found this is important because if you perform the click and then you took the screenshot, you may be on a different screen by now, right? Unfortunately, with the click, you can't take a picture of it clicking, so you kind of have to say, I'm going to click it in a screenshot and then go forward. Screenshots are important for 3 reasons that I call out in here. First of all, you can see what's being tested. So I just joined this, I'm starting to help in this web team now that we're working on the robot pattern with as well. And they have a really awesome test suite. Like there's tons and tons of tests. But the only way to know what those tests are doing would be to look at the code or to be able to go through and literally watch the test runs, kind of like jumping around the screen, like, okay, they did this scenario, they did that scenario. And in this case, it's just going to be the standard out of what I'm seeing in the console logs. Another way I might be able to do it is if I run it in Android Studio, they give me the test report okay, there were 5 tests run here. They took 4 seconds, 5 seconds, whatever it is, and here's the name of it. Right? So as anybody, whether you're a developer or not, even seeing this first test that says test bottom nav hidden on swipe. Okay, I kind of know what that means. Or, you know, like a lot of these things are so granular that maybe it doesn't matter too much. But what's nice is if you can actually do screenshots of each one of these things, then you can get a report that looks like this. So when your test is on executing, you can go through and look like, oh, here's my whole test suite. Let's say you scroll through all of these. And this is our old Capital One wallet app that we used to have. All the cool features of it, locking your card, getting purchase notifications are now in the main Capital One app, so go download that. But at the time, we had the separate app for these sorts of things. But it would walk through, you know, everything in that flow. This is like your happy path, full flow, but it would show you literally every step along the way. So that's super helpful. Right now, anybody can really see what my tests are doing. Even, you know, I as a developer, what was that test doing? I can go back and look. Like trying to parse code versus just look at the screenshots is so helpful. Another big thing for screenshots is diagnosing failures. So right now in Espresso, if you get a failure, you get this like really, and it's red probably because it's really gross, but this huge hierarchy of what the view structure looks like right now. Just like when we looked at the layout inspector, it had the view hierarchy, but it tries to print it out in text. And it's kind of just gross. So in this case, like it's trying to call out that like the done button, I don't even remember, it's looking for capital D-O-N-E, but it didn't find that on here. So it broke the test. What's cool though is if we have this here, we could go ahead and take a screenshot every time something fails. So in this case, like we had a credit card test or whatever, but it failed, and now it's going to take a screenshot of that exact moment. The way that you can do this is you can set on Espresso a global test failure handler. So whenever a failure handler happens, it'll give you the throwable, to the exception that occurred, as well as the matcher that was trying to be used. And so we had this thing called Screenshot Helper that we were using, and you could take it forcefully. The Easy Screenshots library that we published at Capital One, this actually it already sets up the failure handler for you and does that. Does a lot of things behind the scene. If people are interested, please DM me, because the code's all available. It all works great. We've never officially like published it on Maven or on JSON or anything like that because couldn't figure it out. Like it's probably something that we could do in a day or two, but I just need somebody to like poke me and say, hey, I really want this, and then we could take the few hours it takes to figure that out. But it'll go ahead then and take a screenshot, which is super important. So when your test fails, it's great. And I've actually talked to some Googlers about that being probably the biggest feature that I'd want to see. And when I've talked to them, they've said that makes sense. Whether that's actually coming or not is another thing. Like they don't give insight into products and timelines, but we at least know that it's something that everybody's having a problem with. So as I talked about sharing your tests, so this is super important depending on what organization you're in or what people you're dealing with. Most people, when they hear about tests, even I as a developer, when you talk to me before I joined Capital One, you'd be like, all right, tests, like what is even a test? Why does it matter? Like, okay, I could see testing, but you know, whatever, it works. You can really see value in your own tests as well as your bosses, your product owners, your designers, your testers. Like if they can actually see what you're testing. So when you give them a screenshot report that they can scroll through and say like, oh, here's all the things we're testing. Here's what it looks like. The designer can kind of go in and be like, oh, well, the padding of this seems off. Or this seems weird. It just gives everybody a window into your tests. Because otherwise, it's just console output. It's something the developer has to do. So anytime that you show the value of what you're doing and can express that to people and have other people benefit from it, it's a great thing. So I encourage this as a developer in general, right? It's a hard thing for the invisible things that we do, whether it's refactor to a new architecture or whatever, right? Like it's something that's invisible to our end goal of having a product that makes money or helps people or whatever we end up doing. So being able to recognize and show how that helps people and what it does is super important. Because otherwise it's just some hidden tech thing. So let everyone see what's being tested. It's super helpful. That's why I encourage screenshots in coordination with the robot pattern, because as you have robot methods, each one of those can take a screenshot and you're good to go. The whole reason is user interfaces are visual. And really, it's hard to tell what a UI test is doing if you don't have it. So this whole thing was like, tell somebody what the Mona Lisa looks like with, if you had to describe it in words, right, versus a picture, and that would be very challenging. Another thing you can do a screenshot test is you can run them on different devices. So you can run it on the tiniest device you can on the left, or you can do it on a huge tablet device on the right. And you can ensure that your app is actually scaling. So on the iOS side, I'm sure you can I'm not sure about anything, but like you have your your iPhone size and your iPad size, and hopefully you'd be able to tell the differences between those as well. So you can do all these permutations of various things in Android test. What's the size of the device? What's the OS version? Because that matters, right? Like some things work in Android on an old version and not a new version, and vice versa. What's the model? Oh, this version of Samsung S10 device is going to be a problem. This one isn't, right? So you have all these ways of running in all these things. Plus, you can actually, if you support internationalization, which everybody should, then you can see what your app looks like in Spanish, in French, in Hindi, in whatever other language you want to see it in. So being able to see those test reports is super helpful, and we've used Spoon. It was something generated by Square a while back. It's out there on GitHub. You can check it out, and we use that to create our HTML reports. They have their own test runner in there that lets you run all your tests in parallel if you want to, and it generates nice reports. So in this case, I went ahead and I had 70 tests in each run on each device, so 140 tests total. In this case, Spoon actually made it so on the emulator, there's 2 emulators, but one tablet size and one phone size. I went ahead and ran all of them, and then this is the test report. So each one of these little items or elements in that green bar represents a test that was successful. And if I go in, like these UI flows are very large, but it would show you all the screenshots that happened during that UI flow. When you do take screenshots, really what's happening is on the left, I don't have a good like progression here. I can't point either, but you traverse the view hierarchy, what's there, you're generating an image, you're saving that to your disk, and then when the test is run, you use a thing called ADB, the Android Device Bridge or Android Debug Bridge, and then you pull that off, the actual PNG file or whatever, and then you put it in a certain directory structure so that when the report is created, it can figure out what to do. At the time of doing this, there was 3 screenshot libraries primarily. One was Spoon, one was Falcon, and one was UI Automator. Pretty much the Spoon one is not that great. The reason why is it can't capture dialogues and can't capture basically elevation things. So there's actual visual differences here. So the one in the middle, you can see the context menu that popped down, refresh, my group settings. You don't see that on the left. But actually all of these should be displaying the same screen, but it was used with a different screenshot library. That's because Spoon, the implementation I had inside of it, actually just traversed all the hierarchy there, but not anything in the dialogue. So Falcon actually combines those 2 together. On the right, there's UI Automator, which is like a companion to Espresso. And what that does is it actually takes a full screenshot of the entire screen, including like the status bar at the top, like it's 10:11 in the morning or whatever, as well as the device back button and things in the bottom. So anyway, there are a lot of options there. Other ways you can take screenshots if you're on Firebase Test Lab, which is a great way to run your tests in the cloud. They have a library called Screenshotter. Fastlane has a thing called Screen Grab, and when I talked to their developers, it seemed to be basically the same thing as Spoon had. And then Easy Screenshots, I just added this last night, is our library Capital One, which automatically adds the error handler for you and allows you to, by default, it uses Falcon, because we found that was the best one where you didn't want the status bar in it. And then also, it lets you kind of configure it. So even if you want to use Firebase Test Lab and their library, you can configure how you want to take the screenshot and then where you want to save it at. So there's 2 config providers when you start it up. A question I hear about UI testing in general is, should I use emulators or devices? The rule of thumb kind of is use an emulator for your development and for your continuous integration when you're actually creating PRs and things like that. If you want to at times in your own device, like run some there. But I would suggest for the speed of things, really just use it for release regressions, right? Like run it on a large set of devices. And obviously this depends on the feature that you're working on. If it's something that's very hardware specific, like something like camera or something that requires a lot of device specific information, then maybe emulator isn't your best shot. But a lot of the basic things, rendering views, navigating your app, emulators work well for that. They're cheap and they're fast. And you can build them on the fly. So the Android emulator is nice because you run real versions of Android, you can configure it. Yeah, like I said, it's faster than a real device and on-demand and scalable. And they're just cheaper and lower maintenance. So if you look at Google Firebase Test Lab or Google Test Platform, whatever it's called now, it's way cheaper to run Android emulators than it is to run real devices. Because they have to literally have a USB connected device sitting there in one of their data centers versus like being able to just take a node on Google Cloud and just provision a new one and say start an emulator by running software. One thing we did say on the bottom here is when you do screenshots, the recommendation was to actually do it on low density devices. So at the time, it was like on MDPI, which is on Android. It's not the lowest; it's like medium density pixel index. So it's basically the number of pixels per size or whatever, right? So you might think about a TV screen, right? So you have like the old 720p or the 1080p and now the 4K. Your screen is actually going to be the same size, but it's the number of pixels actually pushed into that amount of size. So the higher the pixels, like a 4K TV, has so many more, so everything's going to be more clear. And so the idea was if you have like the lower resolution ones or the lower density, then it actually, the screenshots are smaller, and therefore that part of the process is a little bit faster. So it's not required, but if you want things to run fast, that's a recommendation. So, any questions so far? All right, challenges. So challenges you may run into in Espresso tests are shared state, crashes, and debugging. The shared state would be the fact that I ran test 1, then I ran test 2, and it always passes. But now I ran test 2, and then I ran test 1, and now it crashed. Right? Like this is an issue that we want to mitigate. So there's a lot of things we can do for that. Another thing would be like, okay, cool, it crashed during this. How do I figure it out? How do I debug and figure out why it crashed? Shared state, you can do things like clearing the preferences, clearing databases. There's a really cool library called Barista by this team out of Barcelona that did it. It's an open source library that has JUnit rules that do some of these things for you. So I've used that, and it's pretty great. You're clearing files, databases, preferences. But then it's your job to reset singletons. So in general, we say, as developers, try not to use singletons. At least it's not static, right? But like you are having to, with your dependency injection at time of when your application's created, you go ahead and create maybe an object graph using Dagger or using Coin or manual dependency injection. The thing is, once you create the singletons, let's say there's a counter on it, right? The counter goes to 1 to 2, you start your new test. You want to make sure that's set back to 0. So the idea is like every single time you start a test, you would make sure that that's kind of like recreated. And same with static variables, try to avoid them, but sometimes it's possible. And using dependency injection kind of like allows you to solve for this. Also, if you have any background work, you get kicked off. So this isn't really a problem now because the Android test orchestrator actually stops the process and then starts a new one, so you don't end up with these problems. But these were things that were historically problems, and depending on what test runner you're using, it could still come up. So I love this little whack-a-mole thing where you get rid of one problem and then you open another one. So the JUnit runner, I don't know how deep I want to go into this, but basically I think I went into this before because there was such an issue of how do I make sure that my tests are run in isolation so I don't get that shared state problem. I'm going to kind of blow by this because there is something from the Android test orchestrator that allows you to run each one in a new process. It does make your tests slower. So if you can do other ways, it might speed up your regressions and so forth, but it is a lot more stable and less prone to issues. So I'm just going to kind of skip by that. The main thing is isolated test execution, as I mentioned, though. So what's nice is, you went ahead, ideally you would go ahead and install an app and run the exact test and be done. And then the next one you'd install an app, run the test, and be done. And that's pretty much what it's saying. It's like there's no shared state. It's completely like pretty much a brand new install, and that would work that way. So I forget his last name, but Drew, he's a Android engineer at LinkedIn. He wrote this thing called Dex Test Parser, and he also wrote a library called Test Butler. But they're both really awesome tools that were done to like help Android testing. And previous to all this stuff, like the Android Test Orchestrator like lets you does all this for you. But previously, he actually had to write code that found the test APK, pulled the DEX from it, parse the DEX to figure out all the test files, the test methods itself. So then he could like split those up and traverse them. So like there was a lot of backward stuff that had to be done in the past. But basically, run each test individually and combine the results. The Android Test Orchestrator was announced in 2017 and solves this for you. Sorry for old stuff, but we don't have to do all this crap anymore. Yay! I love this picture. Maybe it's just because like it's connected in my brain to this time that Test Orchestrator was announced, and I was like, yes! Finally! We have something that works! I'm having to whack-a-mole everything. So anyway, this conductor makes me happy. But what it does and the way it works is it actually installs the actual app itself. then it installs a test app, and then it installs another app called Orchestrator. And if you look on the right, Orchestrator is the bottom app. It's another process. And so what it allows to do is you actually talk to the orchestrator, and then the orchestrator is on the app and is able to like run various tests and clear various things. So that's how it ends up working. Then you end up with no shared state, no isolated crashes, and isolated debugging. Yay! We talked about earlier like what you want to test. And I showed a few flows that are like, from the first screen of your app all the way to the last screen of your app, going through every single thing. We call those smoke tests usually if they go through everything, something that just kind of makes sure the whole path works. But ideally, all tests should be like small and targeted. They should go over maybe like one screen, maybe two screens combined, but not go through the whole flow of your app. And the reason is because it's just a little bit easier to maintain. The way that you do that is you have a thing called an activity test rule, where you can launch a certain activity. So it doesn't have to be the first activity your app always uses when you click the launcher icon. It can actually be whatever activity in your app. Typically, though, like if you have, let's say you have a login activity and then a home activity or something like that, right? If you just launch the home activity, usually your logic in your app would say, hey, kick you out of there, you're not logged in. So what you can do is you can basically set up all of the state in your application using Espresso to basically say, hey, this person's already logged in because I set some value in memory, or I did whatever I needed to do to make my application think it's logged in. And then by doing that before your test actually starts, you can literally launch the home screen and then do whatever you're going to do. So this is kind of what you should be doing, is really only testing the exact part you want to, and not go through whole flows. So the reason being, like, if your login page breaks and every single thing goes through that, like nothing's going to pass. Plus, it takes longer. And you want to isolate expected inputs and outputs just for a certain thing and not for a whole flow. Just the main thing of it is skip to the important part, right? Like, what am I really trying to test here? Let's not test the whole flow over and over again. So, I talked about this a little bit, but Hermetic and Deterministic tests. Whenever I say these words, it makes me sound smart, but I finally understood what they mean, and I want to share what they mean with you so you can use these wonderful words with your team. Hermetic. Do I actually have definitions of these things? Oh, I guess I do over here. But I'll just say it out loud first, and then we'll see what my slides say. So Hermetic means that everything is happening like within this bubble, right? There's no outside world is really what it means. So I've heard people say like, a package is hermetically sealed, right? So basically, like if you have plastic wrap and it like sucks all the air out, and it's just like this perfect package. So when you open it up, it opens up. It's something where there's no contact with the outside world. So hermetic means, there's no external factors. Deterministic means every time you execute something, it's going to happen the same way each time. So these are important because you don't want things in the outside world affecting what you're testing. And you don't want your test to run one time and have one result, another time and have another result. So those are two things that we care about. And let's see how I explained it in 2017 and how I will explain today. So mocking out, and I said mock, I think faking is another word that we use these days because Mockito and mocks itself is something that are slightly controversial. So I would say like kind of fake everything out that you want it to use. So whether that's a networking endpoint or whether it's a Bluetooth or whatever it happens to be, a database, fake that out, mock it out, whatever you want to do, just to make sure it's not the real thing. So here's some awesome slides from that I/O presentation that like made me just so happy inside when I finally test Orchestrator and everything else. They talk about hermetic testing and how normally your app talks to things like camera or the watch or to the Wi-Fi or to the networking. But your app, what you're testing, isn't testing those things. Like there's some integration tests when you're sitting down manually and like making sure like, okay, I launched the camera and then it returned a picture. But what you can do is you can actually go ahead and when you click on a button that normally would launch the camera, you can actually just have it return an image, like fake that out. So that your flow really is just about the screen you're on and the fact that you're picking an image from an image gallery and now loading it on that page. So that's kind of what this is talking about. So when you pass between intents, like you can say, start activity for a result or go out and launch the camera and return this thing. There's a thing called an intent matcher. So for Espresso, you can put this in, and it basically says, if the intent sent out to the system matches this, actually return with this activity result. And what that does is short circuits it from having to go out. It actually just like in the Espresso level captures it, doesn't let it go out, and then returns back this fake result. And so that really improves testing a lot. Espresso intents are awesome. Continuous integration. Please, run your tests all the time. It's hard to get it set up to do it, but the benefit is so huge when you do. Because continuous integration will make sure your tests actually stay up to date. They're actually passing. Because, you know, it passed last regression. I'm not sure why it's failing now. And then at the point when it's like you're about to release your code and go through regression, you're like, well, I think that's supposed to fail now, right? Like, as a developer, you want to stay proactive on all these things that you want to be doing so that you don't end up with tech debt. So run them every PR. You know, if you have to, start with a local machine. Just have it be your extra laptop that runs these things. Run it on Jenkins. But, you know, eventually move to something like Firebase Test Lab and have it more scalable and, you know, GitHub Actions and do things in the cloud if you can. So Android tests, Espresso tests are faster than how you could do it some other ways, but running tests in general take a long time. When I showed a few of those examples, it took like 5 seconds for a test to pass. And if you have 100 tests, that's 500 seconds, which is a lot of time. I'm not that good at math. But it's a lot of time. So what you could do, though, is if you had 100 tests that took 5 seconds, you could actually split them up to run on 5 different devices, and you could run 20, 20, 20, 20, 20, and then it should run 1/5 faster, or whatever, you know, or 5 times faster. So definitely use that. When you run on the cloud, like with Firebase Test Lab, you can do tons of crazy sharding in order to achieve that. But then you're able to get your results sooner. So as a developer, when you're putting that PR in, you know, it's getting closer to code lock, or you know, you really want to get your new feature in. You don't want to sit for 2 hours and then have it come back and see like your test failed. Like ideally, you want to hear back within like 10 minutes is like ideal world, but maybe 15 minutes or 20 minutes. All the tests run, what's the result? Because you want to be able to like go ahead, react to that, make a change, run it again. So there's obviously cost involved in this, but if you're at a critical, you know, making a critical app, these things are important, and you might be able to like pay for it. So I'm going to kind of leave with some words of wisdom before I jump into the tangent of Jetpack Compose. But Don Felker is like one of my mentors in the Android world, and this is a tweet he did in 2017. Again, this is dated. But unit and integration tests are the anti-anxiety medicine for developers. The moral of the story is write more tests and ship higher quality apps. One of the first big projects I was on at Capital One, I remember just having this, I had a conversation with one of the QA testers. I was like, oh my gosh, what about this scenario? What about this scenario? Like we tested it, but it's not going to work every time. And so like, I had this like feeling that like, oh my gosh, like there's so many things that could go wrong. Like, is this actually working or not? And that's really when I picked up this testing stuff. And I was like, oh my gosh, my anxiety goes down because I know I've tested all these scenarios. I know this is going to work. I know it runs on every PR. And it just makes you sleep better at night, but also just makes you confident because when you have a good test infrastructure and good test, a lot of tests on there, then you can go ahead and feel confident about refactoring, right? Because underneath the hood, I might change my MVC model to MVP to MVI or whatever else. But if my UI tests are describing what I'm testing from the outside, it shouldn't matter. Those should all pass, and they should help me validate that the actual like what the app is supposed to do is still working. So I'm going to kind of jump here to Jetpack Compose and how testing will work with that. So I'm going to open a new window. Jetpack Compose testing. Yeah, I had this open last night. So I'm kind of just reading from the documentation, but I figure I can give you context based on how we just discussed the slides for Android. So if you don't know Jetpack Compose, basically you write all of your UI in Kotlin. It's all code. It's different. But the way it works is, and I don't have a great visual here, is if you've heard of a canvas element or just something like a 2D canvas where you can draw stuff, you might typically think of this like a video games, but it's literally just, what are my pixels, and it shows pixels. So, the same way you render like a PNG or a bitmap, it's just pixels that render on the screen. This is how Jetpack Compose, the end result ends up being. It's just Kotlin code that ends up rendering a 2D image. That being said, it's very different than the Android view hierarchy system, which that one, there's actually, just like DOM elements are in HTML, there's like literal things on the screen that are rendered individually, and they're kind of all rendered together. And so what's neat about this is we can't use Espresso on Jetpack Compose. The reason why we can't use it is Espresso and all the hand press matchers and everything we get out of it are targeted specifically for Android views. So like the idea of target this element with this ID. That is an Android view ID. It's not something with Jetpack Compose. So semantically, there's still there is a hierarchy though of composables in Jetpack Compose. And if you haven't gone into this, I'm sorry, I might be kind of skipping around, but if you're aware of Jetpack Compose and composables being a UI element on the screen, like kind of basically like a view, but not quite. Then what you could do is, let's say this is a composable, right? A composable in this case would be a button. Inside of there, you'd have an icon composable and a text composable with all the right like modifier paddings on there. In this scenario, you can add semantics. And so this is how we're going to actually expose something that's rendered to a 2D canvas to some things like accessibility. Because accessibility on Android actually reads from the view hierarchy at this point, and then can read off to somebody that's visually or that has a disability. So if we go ahead and we use these things like semantics, you can now add something like to this like text. I want you to have the like down here. I can add semantics to it to say like the text should be this or whatever it is. So the UI elements in Compose that are rendered to the screen will only have those sort of things if you add it to it. So other than that, you're just rendering a 2D canvas. But this gives us the capability to do things like accessibility. It gives us the ability to do things like espresso matching. And that's kind of the way it works. The difference being that when you actually run it, you just like any other test you'd have right now with Espresso, you have an activity that launches up. The difference here is you're actually setting the content to be your composables. That's fine. Just pretend like all this happens, it launches your activity, and then your Jetpack Compose code is on the screen. The difference is these selectors are supposed to look just like Espresso, but they're not quite the same. So instead of on view with this, it's on node. Because each one of them is kind of like a node that ends up rendering to the 2D canvas. But anyway, the selectors are slightly different. They're based on the semantics that are part of, going to be part of accessibility and things like that. But that's kind of how it works. So here's some of the ways you can on node, and you give a matcher just like we have. And so, on a node that has a button this, very much Espresso-like, but it is different. And anyway, that's generally the idea. So I'm going to go back to my final slide to say we're done. Yay. I can open up to any questions, but I'm super excited about Compose. That's kind of like what I do in my spare time now, is I tinker around with it. I think it's going to be really, really cool and powerful to write apps in it. And what's nice is the way that they've designed it here in the documentation they have now will allow us to seamlessly integrate the view hierarchy system we currently have, as well as composables. And so through there, we may have to have our selectors and so forth be different to be able to navigate an application. But I can have one screen that has a toolbar that is written in the normal views, and then a composable that is actually the view, and we could still actually run a UI test through, a combination of Espresso in this.